All right, so today we're going to talk about prisms and the volume of a prism. Now, first of all, let's talk about volume. What is volume? All right, volume is, we use it in a couple different contexts. Sometimes you think about volume in terms of like when you're watching TV or you're watching on your laptop, you say turn the volume up, right? Sound, how much sound we have. When we talk about shapes, three-dimensional shapes, we're talking about basically like how much space something takes up, how much to fill up something. So, for example, if you've ever gone on a trip and you're trying to stuff everything into your luggage, okay, that's a volume problem, right? You're trying to fit so much stuff into a bag that only has so much space, and the amount of space that the bag fits is the volume of the shape. All right. So we have every time you do that with your backpack, every time you're trying to fit something in something else, that's what you're talking about. You're talking about volume. Okay. So that's what we're dealing with today is volume of prisms. Now we talked a little bit about prisms on our last lesson. Okay, remember prism is a three-dimensional shape, and I like to think of it as basically like a shape that's kind of stretched out. And we talked about the difference between a pyramid and a prism, right? Pyramids meet at a point, and prisms they don't meet at a point. They're the same upside down and right side up because they have the same bases. Okay, and then they also have rectangles all the way around. So we're going to talk about the two shapes today: rectangular prism and triangular prism, and we're going to find the volume of each. Okay, we're going to find the volume of each. Okay, so let's draw this out here. First of all, let's talk about the rectangular prism. All right, so we're talking about rectangular prisms. Let's go ahead and draw one here. I'm going to draw one with more of a squarish base here. So you can just draw what I'm drawing on my screen, the best of your ability. I'm going to start with essentially a square. Okay, so when we start here, remember when we did area, we talked about this being a base and this being a height. And you just multiply the two, right? Base times height, and you get the area. Well, think of it this way. Let's say that you had one layer, and that's just the base times height. But if you added another layer, it'd be the base times height times 2. Now, if you added yet another layer, it'd be the base times the height times 3, right? Like you keep adding layers, and however many layers you add is basically what we're going to call the length of our shape. So before we get there, let's go ahead and draw the other square that's the same size. All right, so it should be about the same size, and I put dotted lines for the back, the ones in the back there. And then remember what we're going to do next is we're going to just connect. Okay, we're going to connect those two. So it just seems like two kind of random squares, but actually when you put them together and you connect, you end up with a cool 3D shape. So again, think about it. Basically, if you think of it as just a stack of all those squares in front, and you add up and you keep adding those squares, and however many layers you have, is we're going to call that the length. We're going to use a cursive L. The reason why we use cursive L is because regular L looks like the number 1. So we have the base, we have the height, and then the length is kind of like how many layers there are of that base times height. Okay. So how do we get the volume then? The volume is how much fits in there. So all you're going to have to do is really simple. There's a really simple formula. Volume is equal to base times height times length. All you're going to do is multiply the 3 numbers together. Volume is equal to base times height times length. And it really doesn't even matter which one you call the base, the height, or the length, because you're just multiplying all the 3 numbers anyway. So if you want to call this One way I like to kind of put it is saying like this is the base area, like this is the area of this, times the base length, or sorry, times the length, or sometimes they call it the height of the whole shape. So you might see that the word height. So that's why I try not to use the word height to confuse you, but you're basically taking this green box here and then multiplying it as many times as you can with the length. So let's just give it some numbers so you guys can see. Let's say that this base was like 5 centimeters, and this height was also 5 centimeters, and you'd say this length was 8 centimeters. So our volume would simply be base times height times length. So 5 is the base, times the height, which is 5, times the length, which is 8. You have your calculator there. You do 5 times 8, and you get the volume is equal to 200. Now the units, okay, the units are centimeters cubed. Because basically what you're saying is, I'm using this number cube here, okay, as an example, is you're saying how many of these number cubes would fit inside of my shape if it went 5 across, 5 up and down, and then 8 going backwards, right? That's what you're trying to figure out, is how many of cubes would fit in this shape, okay? So if I had a cube here, let's see if I can draw it. Okay, like how many cubes would fit in this whole shape? That's what you're trying to figure out. And it's 5 by 5 by 8. So pretty simple, right? For a rectangular prism, all you have to do is multiply those 3 numbers. Some people call it the length, width, and height. I'm going to call it the base, the height, and the length, just since we already used base and height for our other calculations. Some people say the base area times the height. That's another way to do that. Okay.